Hi, welcome to A-Level Physics at saltash.net Community School. My name is Mrs. Bovey and I'm part of the physics teaching team here at Saltash. I'm just going to do a little bit of an introduction really to all those who are thinking about doing A-Level Physics and why you might want to do it. Remember, do look up at the stars and not down at your feet. This is one of my favourite quotes from Professor Stephen Hawking, because he encourages us to try and make sense of what you see. It's from the really big, massive ideas of the universe down to the smallest, tiniest little neutrinos and quarks that we're really looking at. We're trying to find out what everything is made of, and that's what we do with A-level physics. Okay. The most important thing is not to give up, to keep trying. So this is an introduction to the content and the course. It's a study of nature and the properties of matter and energies and the interactions between them. So there are lots of fields of physics, okay, and you'll be familiar with quite a few of them, whether your teachers have called them mechanics or just talked about forces, whether we talked about electrical circuits, thermodynamics, why things get hot or cold, and we've looked at sound and light, all at GCSE. We haven't done as much of cosmology and astronomy as perhaps you'd like, but we will be doing a little bit more of that later in A-level physics. Okay, so why should you take A-level physics? Well, primarily because you really enjoy it. That would be the first reason I would say to take A-level physics, because if you enjoy it, you will get a lot more out of the course. But also, there are huge amounts of skills left with A-level physics. So we'll be looking at how we use data, presenting information. We'll be doing all sorts of different ways of informing people of your data, research techniques. There's obviously a lot of maths in there, but also the qualities that you'll gain from this are to persevere. It's not an easy subject, and you won't always get things the first way. Even if you found GCSE physics relatively easy and you think you get all the concepts, I promise you will be challenged at A-level physics. There will be things where you really think, I don't know how to do this, and yet you will get through it if you persevere. Of course, it will challenge you intellectually as well. You'll need to be dedicated and organised, and you will need to have independent thinking and communication skills. There are lots and lots of different careers. I'll go into those in a minute, so don't worry that I'm blocking your sight at that. But just generally understanding physics, questioning it, inventions, creating new ideas, all of those are sort of born out of a A-level in physics. Another reason for those of you who are financially a little bit more astute, okay, first of all, if you're not sure what you want to do post-16, consider doing A-level physics. As you can see from this graph, there are a lot more A-levels open to those sort of maths and physics type A-levels, and so therefore, even if you're not sure what you want to do now, taking an A-level in physics will certainly open up a lot of possibilities to you. And of course, we find that those who are studying the sort of engineering and physics and go on to study those traditionally earn a little bit more than those who do other degrees. Okay, so some of the careers you might want to go into, these may not look like traditional physicists to you, and yet they all are physicists. Okay, whether they're working in the medical industry, whether they're working on acoustics, whether they're working in space or in the armed forces, they're all physicists. Okay, so here are some courses that when I was looking up that physics could lead to for you. Okay, and some of our students have recently gone on to study all sorts at university, but also to go on to different apprenticeships as well, with their engineering backgrounds fully classified with the fact that they've taken A-level physics. Okay, so the course that we're offering is something called Salter's Horner's Advanced Physics. Okay, now this is a less traditional A-level physics. It still teaches all of the same content, but it's packaged up in a different way. So, first of all, it's only available as a linear course, which means that it's 100% assessment at the end of 2 years. So your assessment will be taking place in summer 2023. There will also be progression tests, and we do mini mocks available quite throughout the year, both years, and that will help us to assess and support your progress during this time. Also, the key points there are that the core content has been set nationally. So whichever way we teach the A-level physics, all of the core content will be the same throughout all the different A-level physics ideas. The Salters-Horner's approach means that we start off with concepts and we work through that to try and increase your interest in understanding you're applying physics to real life situations. There's no coursework or practical exam anymore. However, 40% of the examination questions will have a mathematic focus, which is why we really strongly advise that you've done really quite well in maths at GCSE to come onto this course. Okay, in year 12, you'll be studying 7 of these different units here. You'll recognise, not from the names, but starting to understand, so the Newtonian physics, that's the forces, and the S equals ut plus half at squared, all those sorts of equations that you will start to recognise. With the sound of music, looking at the waves and properties of light is covered within that, as well as doing a little bit of lens work as well. The good enough to eat. Now this one is one of my favourites that I get to teach, which is all about how properties of solids and liquids within the food industry. So this is something you might be already aware of. I'm just going to do a little mini demonstration here. Normally, if you were coming on live, I'd be able to show you this. So you all probably recognise I've got some corn flour starch here. If I just hold it up to the camera. And when I, first of all, if I quickly try and scoop it, I can scoop it quite well, but quite quickly it becomes quite gloopy. However, if I scrape it off, I can then snap it quite easily. Okay, now this property is called thixotropy or thixotropy, and we'll be looking into that and many other different performances of the solids and liquids within sweets and within other materials as well within that one. Spacecraft as well, technology in space. We all find space quite exciting, and we start looking at what is taken to keep our all of the stations and the power stations and things like that working up in space. So we get to look at satellites and how the solar panels work and why they are needed, and the sort of quite harsh environment that space actually puts onto our technology that we put up in space. Furthermore, we look at digging up the past, okay, and looking at how we can examine artifacts and the work on the electromagnetic radiation and waves and how they can be used to identify how old and where they may have come from, which is quite exciting for those who are thinking of going into sort of archaeology. We also look at the spare parts is looking at materials used in bones and joints. So again, we're looking at the physics of materials. And transport on track as well, looking at designing and operating a modern transport industry, and that's again looking at mechanics and the electromagnetic forces, which is quite exciting. Right, going into year 13, we have the medium is in the message. Okay, so we start looking at sensing, sending, receiving, displaying information, and looking at electric fields, current and charge. So this is again coming back, we brought that in technology and space, and we start further delving into those sorts of concepts, along with particle physics research in probing the heart of matter and magnetic fields, and looking as well with the atomic structure again, so looking more and more in depth in year 13, earthquakes and finding out how we can try and see if we can detect them earlier, looking at simple harmonic motion, and also looking at temperature control as well in buildings, and how modern buildings definitely have got the engineers and physicists keeping an eye on those. Finally, we get to look at exploring the star properties. This is really exciting for those of you who are looking at astrophysics or anything to do with looking into the cosmology of our universe. Right, now, a lot of you may not have come across this before. So instead of having any sort of practical exam, we now have a practical endorsement. These are 16 core practical activities which have been identified on the specification, and 12 of these must be completed. So we will start in year 12. We've already done a couple with our year 12 students this year, where we tell them it's happening. The idea is over the course of 2 years that they will have chance to experience all of these different practical activities, and it will be done on a sort of pass or fail basis, but have no weighting on your final grade. So you could end up with an A star for A-level physics and a fail on the practical endorsement if you weren't there for all of the different times that we were doing them. However, if you weren't there, we normally do catch you up. So please don't worry about that. It's more really, I tell the students, to show the exam boards that we are preparing them thoroughly in their A-level physics, and they have done all of the practicals that they need to do, because even in the exams they'll be examined on those practicals. So it's really important that the students do get a chance to actually do those practicals themselves. I'm very much a believer that actually by doing you are also learning as well, and I think by doing it, seeing the experiment, getting the data yourself, it's going to stick in your head a lot more. Okay. So you'll be examined over 3 papers covering all topics on the 2 years. 40% of the marks come from mathematical skills, so it's really important that you are secure in your mathematical understanding and knowledge by the time you start the A-level. There will be a focus on practical work in one of the papers, so they will look at all the practicals that you've meant to have studied and we will have studied, and you'll be tested on those as well. Literacy is being assessed in your long answer questions, and the papers 1 and 2 contribute to 30% of the final grade, whilst paper 3 covers more practical elements and contributes to 40% of your final grade. Right, so what do we require? Okay, at least 5 good GCSEs required. A grade 5 in physics or combined science, and a grade 5 in the higher paper of GCSE maths. The foundation paper doesn't fully cover all of the mathematical skills that we are hoping that you will need for your GCSE. So please try and aim for as high as you can, bearing in mind that even those with a grade 6 will probably struggle a little bit more. So do try and get your 6s and your 7s and your 8s if you want to do A-level physics, because you really do need that core knowledge and understanding as we move you on into the wonderful world of A-level physics. Okay, you do need to be prepared to work hard. Even if you've got yourself your 9s and your 8s at GCSE, you will find it another step up into A-level physics. You need to be organised, you need to be independent and resourceful. You need to be prepared to look things up and work things out yourself. Don't give up at the first point. Keep going, keep trying to work it out, keep talking it through, and you will get there. So, what goes on in lessons? This year we've got 3 separate teachers, myself, Mrs. Blackmore, and also Mr. Allen. We're teaching 3 separate components, but normally there's at least 2 teachers who are going to be teaching the A-level physics course, and you could be carrying out practical investigations, problem solving, using computer simulations, working through problems in small groups, discussing or debating the applications of physics, researching ideas and presenting them to others, or reflecting and reviewing and revising work. Okay, what do we give you? Well, we give you a textbook and a CGP revision guide to start with. The course materials we give out as specification, and you get a Welcome to Physics booklet which has the checklist for your first 3 units in it. You'll also have access to online revision materials which we've signed up for, and also Edmodo. And of course, when you need that little bit of extra help or support, you don't fully get something, of course we will be there for that individual monitoring and support and those extra little helpful sessions which just get you back on track. So, have I convinced you that physics is or is not for you? Do you like a challenge? Are you interested by physics? Are you interested in one of those careers that I mentioned? Do you enjoy science, particularly physics at GCSE? Do you enjoy ICT and maths? Do you like practical work? Do you like finding out and researching new ideas? Can you cope with not getting something straight away, but having to really work at it? Do you get that sense of achievement when you do get something that at first you didn't get and then you get it, that wow moment? Are you willing to work hard and do whatever it takes to do well in physics? Ultimately, do you like physics? If you do, then you should enjoy our course. Right, now I can't give you any questions. However, my email address is nbovey, that's N for Nicola, nbovey @saltashcloud.net. And any questions you've got regarding the A-level physics at saltash.net, please forward them to me. Thank you very much for listening. Bye.